Hello everyone! Have you ever wondered if you could predict who might have survived the Titanic's fateful voyage? What if I told you that with a bit of data and machine learning you can... Ready to dive into the depths of predictive modeling with the Titanic survivors prediction model. In this video, we'll build a logistic regression model that uses 5 key inputs. Passenger class indicates the class of the ticket purchased, which can affect survival chances due to varying levels of access and priority during the evacuation. Sex refers to the gender of the passenger, as historical data suggests different survival rates for males and females. Number of parents or children aboard the Titanic represents the number of family members traveling with the passenger, which may influence their likelihood of survival due to familial connections and priority. Passenger fare, the amount paid for the ticket, which can be indicative of the passenger's class and access to lifeboats. Port of embarkation, the location where the passenger boarded the Titanic, providing context about their journey and potentially influencing survival based on boarding location. Based on these inputs, our model will predict whether a passenger was likely to survive the Titanic disaster. Logistic regression is the go-to technique for binary classification tasks like ours, where we predict either survival or non-survival of passengers. It works by modeling the probability of a given input belonging to one of these two classes. This makes it an ideal choice for our Titanic dataset. First, let's set the stage by importing the necessary libraries. These tools will help us load and manipulate our data, create visualizations, and most importantly, build and evaluate our model. Now, we load the Titanic dataset, the heart of our project. This dataset includes information about each passenger, such as their age, gender, ticket class, and whether they survived. Understanding the variables in our dataset is crucial as they form the backbone of our predictive model. Survived. This is our target variable. It indicates whether a passenger survived, 1, or didn't survive, 0, the Titanic disaster. Our goal is to predict this variable using the other features in the dataset. P-class. This represents the passenger's class, with values ranging from 1 to 3. 1 stands for first class, 2 for second class, and 3 for third class. The class indicates the socioeconomic status of the passenger, which may have influenced their chances of survival. Sex, a categorical variable indicating the gender of the passenger, either male or female. Gender likely played a significant role in survival rates, as women and children were given priority during the evacuation. Age, this represents the age of the passenger in years. It's a continuous variable, and it's crucial to consider since age could influence survival chances, especially for very young or elderly passengers. SIB-SP. This variable counts the number of siblings or spouses aboard the Titanic with the passenger. It gives us insight into whether traveling with family impacted survival chances. PARCH. Similar to SIB-SP, this variable indicates the number of parents or children a passenger had on board. Family presence might have had a role in the survival odds. Ticket. The ticket number is a categorical variable representing the ticket purchased by the passenger. Though it's a mix of alphanumeric values, it might provide some clues related to groupings or cabins. Fare. This represents the fare paid by the passenger for their journey, a continuous variable in currency. The fare can be a proxy for the economic status of the passenger, possibly affecting their likelihood of survival. Cabin. This is the cabin number assigned to the passenger. It might give us information about their location on the ship, although it's missing for many passengers. Embarked. This categorical variable indicates the port of embarkation, C for Cherbourg, Q for Queenstown, and S for Southampton. The embarkation port might reveal some regional factors affecting survival. Before diving into modeling, let's explore and pre-process the data. We'll start by examining the structure of our dataset, which will help us understand the data types, identify missing values, and decide on any necessary cleaning steps. To get a better understanding of the numerical data, we can generate descriptive statistics. This gives us insight into the distribution of features like age and fare, crucial for making informed decisions during pre-processing. Identifying and handling missing data is a crucial step in data pre-processing. We visualize the missing values to pinpoint columns with a lot of missing data, helping us decide the best strategy to fill or drop them. Visualizing data distribution. Understanding the distribution of key variables like survived, sex, and p-class through visualizations helps us spot trends and relationships in the data. These patterns will guide us as we proceed with feature engineering and model building. Plot a histogram of the age column to visualize its distribution, excluding missing values. Plot a histogram of the fair column to visualize its distribution. Next, we'll address missing values in critical columns like age. Instead of a simple mean imputation, we'll take a more nuanced approach by using the average age based on passenger class, which correlates with age. Drop the cabin column, which has too many missing values. Remove rows with any remaining missing values. Now let's check that heat map again. Remove any duplicate rows from the data frame to ensure that each entry is unique. Identifying outliers in numerical columns. Plot box plots to identify outliers in numerical columns like p-class, age, sib-sp, parch, fair. Plot histograms for numerical columns to visualize their distributions. We also identify and handle outliers using z-scores, ensuring that extreme values don't skew our model's performance. This process fine-tunes the data for better model accuracy. Exploring categorical columns. Check unique values for categorical column. Display the frequency distribution for each categorical column. Feature engineering. To make our data machine learning ready, we convert categorical variables like sex and embarked into numerical formats through one-hot encoder and LabelEncoder respectively. This step ensures that our logistic regression model can process these inputs effectively. Drop non-essential columns like name and ticket, which don't contribute to the model. Finding correlation. Compute the correlation matrix for all numerical features with respect to the target variable, survived. Visualize the correlation of each feature with survived, helping to identify features with strong correlations. Drop columns with low correlation with the target variable. Model building. With a clean and prepared dataset, we now focus on building our logistic regression model. We'll split the data into training and testing sets, train the model, and evaluate its performance in predicting survivors. Model prediction. Finally, with our model trained and ready, we'll make predictions on the test set and evaluate its accuracy. This step will tell us how well our model performs in predicting who would survive the Titanic disaster. Model evaluation. Display the confusion matrix showing the true positives, false positives, true negatives, and false negatives. Provide a detailed report of precision, recall, F1 score, and support for each class. Calculate the accuracy of the model, which is the ratio of correctly predicted instances to the total instances. Cross-validation. Perform cross-validation by splitting the training data into 5 parts and training the model on 4 parts while validating on the 5th. The process is repeated 5 times, and the mean accuracy is calculated to assess model stability. Model deployment. Save the model to a pickle file. Load and use the model. Load the trained model from the pickle file. Take user input and prepare the data for prediction. Predict the output based on the user inputs. Find the dataset and code in the description below. I trust you found this video helpful. Thank you.